Hello and welcome to today's video about what 6-mark questions might look like on electricity generation methods. This is What's Your Question? I'm Mr. Watts. Let's go. I've placed here for you 2 starter questions. The first of these starter questions is what is a proportional relationship, and the second one is what's an inversely proportional relationship. Pause the video here, have a go at writing the answers down in the comments or on some paper and see if you know what the answers are. Pause here. Great. So a proportional relationship then is where the ratio between one variable and another in a graph is equivalent. This means that if I double whatever's on the x-axis on the graph, or whatever's on whatever the independent variable is in an investigation, I will double the dependent variable or whatever's on the y-axis of that graph. An inversely proportional relationship is the opposite of this. In the inversely proportional relationship, if I double what's on the x-axis, I'm going to half what's on the y-axis. These both produce very specific graphs, in that a proportional relationship will look like a straight line that goes through 0 always, and an inversely proportional relationship will be a curved line going down like this on the graph. Our objective for today is to have a look at a 6-mark question on what it is we're going to be doing. We're going to make sure we use that decode, plan, answer, check method that I always use in these videos, and you need to make sure that any time you're using any or answering any 6-mark questions, you are doing all those 4 things. You are decoding that question, you are planning what you're going to say, you are looking for exactly what it's asking you to do, you are having a go at answering it, and then you're checking you've done all those things before you move on. If you do those 4 things, you'll be in a much better place when it comes to your 6-mark questions. Okay, so the 6-mark question for today then, I've placed right here for you. It says, Sally knows that several factors affect the current output for a solar panel. She investigates how the current output depends on the distance between the light source and the solar panel. These are her results. And then you can see on the graph, the top layer is the distance between the lamp and the solar panel in centimetres, and the bottom row is the current in milliamps. It then says to describe and explain how the current from the solar panel depends on the distance between the light source and the solar panel. There's a few really important instructions in there. There's some clear data which you're more than likely going to have to refer to, and there's a diagram just to help you understand what it is that the investigation is doing. If at this point you are not understanding, you can read through it a second time, but it's fairly clear what they're doing. They're placing a lamp near a solar panel, they're changing the distance between the lamp and the solar panel, and they're looking to see how it affects the amount of electricity, the current of the electricity that is produced. The next thing you need to make sure you do is you decode this question. You need to look into this and see if we can find out what the command words are, what we're specifically being asked to talk about, and any key important information as well. I'd like you to spend a few minutes reading through. You can write it down on the paper you have with you, or you can see if you can write down somewhere, or just see if you can identify those things before I do. You need to get into the habit of doing this by underlining words on paper in exams, so writing it down would be a really useful exercise. Write down the command words, write down specifically what the instructions are here, pick them out. You should now have written them down somewhere and have an idea of what the instructions and things are, and I've placed here it decoded. In yellow, I've highlighted the command words in the question to describe and explain. This question's marks is going to hinge entirely on your ability to know the difference between describing something and explaining something. If you don't know the difference, then we need to talk about that now. If we're describing, we're just talking about what it looks like. In terms of data, you're looking for some kind of relationship in the description. We're trying to say, as one thing increases, does another thing increase? As one thing increases, does the other thing decrease? Can I see proportional relationships? Can I see inversely proportional relationships? It's really important that you can pick those out. It tells you that we're going to describe and explain how the current from the solar panel depends on the distance between the light source and the solar panel. So it seems like one question here, but we're describing that, we're stating that relationship, and then we're going to explain it. And explaining it just means we're going to talk about why that relationship is what it is. Why does the distance have the effect that it does? If you don't explain it, there's no way you're going to get full marks on this question as well. I've highlighted in green the results table, because that's the important information here in the question. You need to be looking at that to find the information, and in red, these are her results, because If it says something like that, you're more than likely going to have to look at those. They're really, really important. If it says this is a table of information, you're likely going to have to look at that table of information. Pay attention to the wording they use. It's there to help you. Next, we need to plan out exactly what we're going to do. So we need to write out specifically, if we were in an exam, I'd make a margin on my page and I'd write in that margin, bullet pointed, what things do I have to make sure that I'm going to do, and I tick them off as I go along. So I need you to write out specifically what you're being instructed to do. What's the first question? What's the second question? Because most questions are split into sort of either, they're never one big question, they're 2 3-mark questions or 3 2-mark questions. So what in this question are our 2 3-mark questions to look for? Spend 2 minutes looking at this and trying to work out what they're asking you to do. Where are the marks going to be? Pause the video here, see if you can write them out. You should have found that we are being asked here to describe how the current from the solar panel depends on the distance between the light source and the solar panel, and you're being asked to explain that as well. You're likely going to get half your marks for the first one of those, and half your marks for the second one of those. Your ability to recognise more detail in your relationship is probably going to access the higher end of these marks. So just stating as that goes up is going to be very low marks, whereas as that goes up, oh, this and this have a proportional relationship, is a really, really important here. Can you notice things like that? Does it have that relationship here? The next step is to actually have a go at answering these questions. Use the points we've made here. Use our planned answers to make an attempt at writing something down somewhere. Again, you can do that in the comments underneath and I can look at it and give you feedback, or you can throw it on some paper and you can mark it yourself, because I'm going to go through the marks here at the end of the video as well. But pause here and have a go at answering it. If you don't practice, you won't improve. Great. Now, the last step then, once you've answered it, is to check your answers. Read back through what you've written and double check that you have answered both the things it tells you to. Have you described a relationship? Have you explained why that relationship is what it is? If not, you need to go back through and make sure you add in the thing you are missing. For our mark scheme then, I've placed here what it says in the mark scheme, the most important bit, which level you think you're going to be at. And as I said before, that level 1 stuff, that 1 and 2 marks, is for a simple trend. As this goes up, or any reason why the current decreases as distance increases. If you've got either of those 2 things, you've hit 2 marks. For level 2, you've got to identify the trend and include the fact that it's not linear. So the idea that doubling one isn't doubling the other one. We're not getting a straight line anywhere on our graph. If you mention that, you're getting 3 to 4 marks, and you have to again suggest a reason. If you've done both those things, you're hitting 3 or 4 marks. And for top level 3, 5 to 6 marks, you're mentioning the idea of an inverse square relationship. Now that just means if I double one thing, I'm getting a quarter of the other thing. Yeah? So I'm dividing it by 4. That's what an inverse square relationship is. So if you ever see doubling one variable means that we're reducing the other variable down to a quarter of its size, we call that an inverse square relationship, and you need to be able to identify those with full marks in questions like this. You'd also have to express that it's between distance and current. You have to be specific about that or you're not going to get those marks. You'd also have to suggest a reason why current decreases as distance increases and refer to electrons in some way. If you're not referring to electrons, you're not hitting the 5 to 6 marks in this in any way. So let's have a look then at exactly what the question's expecting you to say. For level 1, as distance increases, the current decreases. In any wording of that, you can get it the opposite way around. As long as it's as distance increases, the current decreases. You could also set the idea that less light means less energy from the light source as the distance increases. So we're going to mention for our relationship there, the top line, and the second line is the idea that there's less light or energy as you get further away from the lamp. We can refer to milliamps instead of current. You would get marks for doing that. At level 2, you'd need to be able to say that as distance increases, the current decreases non-linearly. So we're not getting a straight line downwards, we're definitely getting a curve in some way. Or at a different rate is fine as well. Our explanation again needs to be less light or energy from the light source as distance increases. There's no difference needed in that explanation for this bit here. So we just need to make our relationship more detailed. The idea that you've identified that doubling the distance has not doubled, or it's not doubled or halved the current that's produced. For level 3 then, you need to identify the idea as an inverse square law between distance and the current, as we said before. This is our specific relationship, and you'd have to refer to data. The idea that when you go from 20 to 40, it doubles the distance but quarters the current. Remember, as we said, if you're doubling one thing and it quarters the other one, that's an inverse square relationship. You've got to back up those relationships with data for top marks. Finally, the explanation then needs to be that there's less light energy falling on the panel, so we're knocking fewer electrons loose from the silicon. We know that the more energy there is, the more electrons will be knocked loose from the silicon, so the more current will produce. And if there's less light, less of those electrons are going to be knocked loose. If you have any questions about that, or any of it doesn't make sense to you, throw them down in the comments and I'll happily go through them. But that's our 6-mark question on solar panels. Thanks very much for watching. Make sure you stay safe, stay alert, stay curious, and subscribe.